This is lesson 2, integration using partial fractions, which is probably a review for you from last year. Anyway, before I do the integration, let's take a look at the fraction below here, and that's going to be 2x plus 16 over x squared plus x minus 6. So what does it mean to decompose it? Well, let's come down here and take a look. Suppose I had 2/3 plus 4/2. That's silly, 4/5. And suppose I was trying to add those. Well, I would come up with a common denominator, which would be 15, and I would say 2 times 5 over 15 plus 4 times 3 over 15, and that would give me 12 plus 10 over 15, which is going to be 22 over 15. But suppose I gave you 22 over 15 and I told you to decompose it into this. That's the objective of decomposition, and that will help us to integrate. Anyway, the first step in decomposition is to factor the denominator. So we have the numerator, and I'm going to factor the denominator to be x plus 3 times the quantity x minus 2. These are both considered linear factors, and the question then becomes, what value would go over this linear factor, x plus 3, and what value would go over this linear factor, x minus 2, if I were to decompose it? When I find the values of a and b, I have successfully decomposed the fractions. So start here, and suppose you're adding the fractions. Well, I get a common denominator, which would be this. So let's take a look at the numerators. What would I have to do to the a? I would have to multiply it by x minus 2. So that I have x minus 2 and x minus 2. X minus 2 here, x minus 2 here. Plus b times x plus 3. X plus 3 here, x plus 3 here. Then I would add them. This expression that I have here is just the numerator, and so that numerator would equal the numerator that I desire, 2x plus 16. Now what I'm going to do here is distribute the a and distribute the b, continuing the equality. And again, the only goal is to find a and b, so we're going to set up a system of equations. So you see here I have ax and bx. So if I put those together, I have a plus b times x, and then the other terms, the constants, are going to be minus 2a plus 3b, again equals to 2x plus 16. So what this tells me is that a plus b will have to equal 2 because it's the coefficient of x, and everything else will has to equal 16. This value here. Skipping down, so that tells us a plus b equals 2 and negative 2a plus 3b equals 16. Now, I'm not going to run through how to solve that system of equations. You should know how to solve it. Turns out it's going to be b equals 4 while a equals negative 2. Okay. So now what I'm going to do is come back, I'm going to come back up here to finish my successful decomposition. I have negative 2 over x plus 3, and then b is 4, so plus 4 over x minus 2. A successful decomposition. But that's not it. Now we have to integrate. So this integral becomes the integral of negative 2 over x plus 3 dx plus the integral of 4 over x minus 2 dx. And we have two simple integration problems here. Negative 2 natural log x plus 3 absolute value plus 4 natural log absolute value x minus 2 plus c. That's my final answer to example number 1. Let's take a look at example 2. That's 1 minus 3x in the numerator and 3x squared minus 5x plus 2 in the denominator. Alright, you may want to press pause, give it a try, and then follow along. First step, we need to factor the denominator. And that's going to factor to be the quantity 3x minus 2 times the quantity x minus 1. I surely hope that that won't be the problem factoring. So the question again becomes a over the linear factor 3x minus 2 plus some number b over the linear factor x minus 1. We're ready for our numerator analysis. So a times x minus 1 plus b times 3x minus 2 will equal the numerator, 1 minus 3x. The question is, what would be the coefficient of x? Well, we'd have an a plus a 3b. See that if I distribute it here? Okay, so that would precede x, and then everything else, minus a minus 2b would be the constants. So we have 1 minus 3x. So we see that this has to be negative 3 and that the constants have to be positive 1, giving us our system of equations. A plus 3b is negative 3. Negative a minus 2b equals 1. This will give us the solutions of b equals negative 2 and a equals 3. So we have our successful decomposition. 3 over 3x minus 2 plus, in fact I'm going to make that a minus 2 over x minus 1. And now for our integration, this will be the integral of 3 over 3x minus 2 dx minus the integral of 2 over x minus 1 dx. You have to be real careful here. This one is a straightforward natural log. This one here is also natural log, but would require a u substitution. If I can sneak this in here, where u is 3x minus 2, and du is 3 dx, and dx is du over 3, you see that that's going to cancel out with this 3. And the result of that is going to be the natural log absolute value of 3x minus 2 minus 2 natural log of x minus 1 plus c. And that is an acceptable answer. I do want to take one moment and show you how the calculator might present the answer. So the calculator would take this and write it as natural log 3x minus 2 absolute value minus natural log x minus 1 squared. I just used properties of log, brought this 2 up here. I got rid of the absolute value because it's now squared and I don't need the absolute value. Plus c. And finally, properties of logs. This is going to be the absolute value of 3x minus 2 over the quantity x minus 1 squared plus c. Let's move on to example 3 as shown here. Okay, I'm going to come down below. I'm going to try to decompose. Decompose the fraction, that is. Not myself. Anyway, I'm going to factor out an x. And I have x plus 7 and value of a over x plus the value of b over x plus 7, like that. Our numerator analysis, a times x plus 7 plus b times x equals 5x plus 14. That tells me that a plus b has to equal 5, and it tells me that 7a has to equal 14. Nice and easy one. A is equal to 2, b is equal to 3. Decomposition, 2 over x plus 3 over x plus 7, and our integration, 2 over x dx plus 3 over x plus 7 dx, 2 natural log x plus 3 natural log x plus 7 plus c. I'll come down here to show the calculator version of that. That would be natural log of x squared plus natural log of absolute value x plus 7 to the power of 3 plus c, and then these can be combined as such. And there we have it. Example number 4, this one's a little more tricky. The denominator does factor. The problem is we have some funny business you may not have recognized. In fact, I would try partial fractions to see where you come up with a problem. You will never be able to get this x squared term. So we are looking at this. Turns out that this is an improper fraction, meaning that the numerator is larger than the denominator. If that's the case, I'm going to use long division. So I'm going to take the x squared minus 6 and I'm going to divide x squared minus 9. That's what it's telling me to do. And that's going to go in one time. So that's x squared minus 9. And I have to subtract, distribute the negative. So this comes out to be a remainder of 3. So in other words, I'm saying that x squared minus 6 over x squared minus 9 is equal to 1 with a remainder of 3 over the divisor. Okay, that's just good old-fashioned arithmetic. So that's telling me here then that this integral is equal to the integral of 1 dx plus the integral of 3 over x squared minus 9 dx. I am ready to do some partial fractions for this part of the integral. Okay, so I'm going to factor x plus 3, x minus 3, value of a I have to find, and the value of b I have to find. Numerator analysis. Equals the number 3. Okay, so what is a plus b? What does a plus b have to equal? There is no x, so the coefficient of x will be 0. The a plus b will equal 0. Negative 3a now plus 3b, that's due to the distribution, that has to equal 3. And that system will solve to find values of b to be 1/2 and the value of a to be negative 1/2. So it looks like this: negative 1/2 over x plus 3 plus 1/2 over x minus 3, like that. So where are we here? This integral here is simply x. This integral here is going to be negative 1/2 natural log x plus 3. The next one is going to be plus 1/2 natural log of x minus 3 plus c. I will be very happy if that's the answers that you get. Let's just see if we can't simplify this a little further now, though. So this will be x minus a half natural log x plus 3 over x minus 3, an absolute value. I just factored out a negative 1/2 and then combined with the subtraction. But we could have also said, so here's an alternative, x plus the natural log of x minus 3 to the 1/2 over x minus plus 3 to the 1/2 plus c. And then the 1/2 could have been brought down. What am I doing? I need to stop for a second, because I don't think that's going to add anything new or interesting, so let's just leave it like that. Example 5. The reason for example 5 is not to show integration using partial fractions, but to show you that if you can't factor the denominator, perhaps there's another way. In fact, in reality, partial fractions would come after I would consider other ways. So could you integrate this? This is one actually you should be able to do already. For me, I'm going to factor out a 3, and that's going to give me dx over. Now if I write it as x squared plus 9, that might look familiar, might look Book of Memories-ish. Okay, the problem is, for me to use Book of Memories, this would have to be a 1. So what if I factor out that 9 from the denominator? Then I have dx over, well, this becomes 1, but then this becomes x over 3 quantity squared, or x squared over 9. Now we're ready to integrate that. I'm going to use a u substitution. Actually, let me simplify this first. 1/3 integral of 1 over 1 plus x over 3 squared. I'm not sure why I wrote the x squared term first here, switching it from here. But anyway, we're back to it second over here. Alright, again, back to the u substitution. So u equals x over 3. du is 1/3 dx, and dx equals 3 du. So that's nice because it's going to, this 3 is going to cancel out with this 3, and I'm left with the integral of 1 over 1 plus u squared du, and I sure hope you have that committed to memory. That's going to be the inverse tangent of u plus c. Converting back to x now, the inverse tangent of x over 3 plus c. And I just remembered that I lied. There's actually one more example. Like in example 5, example 6 here is not illustrating integration with partial fractions, but just asking you, can you flat out integrate? Real easy one if you know the trick, real hard one if you try some different things. Perhaps you want to pause and try if you're up for the challenge. Otherwise, check it out. The idea here is that 5x minus 1 over x squared plus 1, this can be considered the common denominator already to two other things. 5x over x squared plus 1 minus 1 over x squared plus 1. So I could write this as the integral of 5x over x squared plus 1 dx minus the integral of 1 over 1 plus x squared dx. I this time intentionally switched them so it's more recognizable. So the second half one is easier. Inverse tangent of x plus c. The first one actually is really easy, but don't get confused here. Don't forget what we've learned in the past. U equals x squared plus 1. Du is 2x dx. And dx is equal to du over 2x. So we see we have these x's cancel out, and I have a 5/2. The integral of 1 over u du. So this is 5/2 natural log of u minus inverse tangent of x plus c, but the u is defined as x squared plus 1. Yeehaw! There it is. Integration. The end.